In this video, we're going to talk about our first method for factoring polynomials, and that is pulling out the greatest common factor, or the GCF. We will use this method as our first method every single time we approach a new factoring problem. So we're always going to look for our greatest common factor. Now, we've already talked about what the greatest common factor is and how to find it. Now we're talking about finding it and then factoring by pulling it out. Basically, we are undoing the distributive property. So let's start with our steps. We're going to start by finding the GCF, which we've already talked about. We're going to divide all of the terms by the GCF. Remembering when you divide with like bases, you subtract the exponents. Then we're going to write it in factored form and distribute to check your work. Now, the distributing to check your work, you can pretty much do in your head. Just be careful with your exponents. That's where people make the biggest mistakes. Taking a look at our examples, we'll start with example 1. So we have 3y cubed plus 3y. Now for our coefficients, the 3's are common. So I'm going to start my GCF with a 3. And then for the y's, remember for the variable, you choose the smallest exponent, which is 1. So my greatest common factor here is 3y. Now, I'm going to come in and divide each term by 3y. And that's going to give me 3 divided by 3 is 1. Y cubed divided by y, I'm going to subtract my exponents, y squared. Plus 3 divided by 3 is 1. Y divided by y is 1. And writing it in factored form, I do my GCF times that quotient. Notice if I distribute, 3y times 1y squared is 3y cubed. 3y times 1 is 3y. So I get back to the original. Let's look at example 2. This one has 3 terms, but I still find the GCF the same way. 4, 16, and 12. Hopefully you can see that 4 goes into all of those. So 4 is our GCF. If you can't see that, then you would need to list all of your factors and choose the smallest one. 4 is going to be the smallest one. For the x's, we have an x to the 4th, an x cubed, and an x. Choose your smallest exponent, which is 1. Then I'm going to divide each term by 4x. So 4 divided by 4 is 1. X to the 4th divided by x, subtract your exponents, x cubed. Minus 16 divided by 4 is 4. X cubed divided by x to the 1st is x squared. Again, subtracting your exponents. Plus 12 divided by 4 is 3. X divided by x is 1. I don't need to write it because the 3 is there holding my place. Again, if I distribute, 4x times 1x cubed is 4x squared. 4x times negative 4x squared is negative 16x cubed. 4x times 3 is 12x. Moving on to example 3. Now, you can see here my leading coefficient is negative, so when I go to pull out my GCF, I'm going to pull out a negative. 9, 12, and 18. 3 goes into all of those. And then I've got x to the 4th, x cubed, and x squared. I'm going to choose the smallest exponent, so 2, x squared. And then notice this first term doesn't have a y, so y is not a common factor. So my GCF here is 3x squared. To get what goes in parentheses, I'm going to divide everything by negative 3x squared. Anytime my leading coefficient is negative, I'm going to pull out a negative. So negative 9 divided by negative 3 is a positive 3. X to the 4th divided by x squared is x squared. 12 divided by negative 3 is negative 4. X cubed divided by x squared is just x. And then the y comes along, because there's no y that's dividing. And then negative 18 divided by negative 3 is a positive 6. The x squareds are going to cancel, and I'm going to have y squared left. On ones like this, it's really important to redistribute and check your exponents. So negative 3x squared times 3x squared does give me negative 9x to the fourth. Negative 3x squared times negative 4xy. Negative 3 times negative 4 is positive 12. X squared times x is x cubed, and then y. And then negative 3x squared times 6y squared, negative 3 times 6 is negative 18. I've got the x squared and the y squared. You can write that step out if it helps you. Okay, example 4, 3, and 5. 5 goes into both of those, so my GCF is 5. And then I've got an x squared and an x. The lowest exponent there is 1, so just x. And the y is not common. Dividing everything through by 5x. 30 divided by 5 is 6. X squared divided by x is x. 2 minus 1 is 1. Negative 5 divided by 5 is negative 1. The x's will cancel, and I'm left with just y. Then if I redistribute, 5x times 6x is 30x squared. 5x times negative 1y is negative 5xy. And our final example. Again, my leading coefficient is negative, so I'm going to pull out a negative. 4, 16, and 6. I was going to say 4 goes into all of them, but it doesn't go into 6. So 2. And then x to the fourth, x squared, x cubed, x squared. The smallest exponent is x squared. Dividing everything by negative 2x squared. Negative 4 divided by negative 2 is 2. X to the fourth divided by x squared is x squared. 16 divided by negative 2 is negative 8. X cubed divided by x squared is x to the first. Negative 6 divided by negative 2 is a positive 3. X squared divided by x squared, they cancel, so they are gone. Once again, redistributing. Negative 2x squared times 2x squared is negative 4x to the fourth. Negative 2x squared times negative 8x is positive 16x cubed. Negative 2x squared times 3 is negative 6x squared. And that is factoring with the greatest common factor.